Alright, so I wanted to finish our building the box activity that we did on Wednesday. So if you would please take this information, alright, and what we're going to do is enter this into Desmo. So we're going to enter in the height and the volume, alright, of each one of these. Heights, volumes, heights, volumes. We don't need the names of the groups. We're just interested in the heights and volumes. So go into Desmos, get a table, type that stuff in. Alright, so pause and let them type this in, please. Oh, by the way, this number is 4. Alright, so you should have those numbers typed in. We've got a table here, and let's see. What I want to do then is be able to see all the data. Alright, so I'm going to go to the little wrench here and change my x-axis to 0 and my maximum here. Let's see, the highest number I have for x is pretty small, so I don't need to put much there. So I'm just going to put 6. All right, my y, all right, I'm going to make 0, and my y maximum about 80, because I don't see anything higher than what I got. Okay, so 0 to 6, 0 to 80, anything about in that range should work. So here's my scatter plot of my numbers. All right, right there. Okay, so we've got somewhat of a curve here. All right, so let's go and figure out an equation that's going to model those data points. And then we can go ahead and talk about what's going to give us our maximum volume. So if we come down to here, and we're going to talk about the volume of this open-topped box that we had. So, how do we find volume of a box? I heard some people say length times width times height, right? Okay, one of the things that we talk about in geometry is that the area of the base times the height is the volume of any shape. All right, so if we look at it from this point of view or from this point of view, it doesn't make any difference because it's the same. All right, it just happens to be a nice rectangular open-topped box. So let's take a look at this. So let's say I have this box that I had, my piece of paper, and I made this border around, which was my height. And we're going to call that distance x. So we're going to have x's here and here. So x is going to be the height that I folded up, right? If that's the case, then this is going to be, let's see, 8.5 by 11. All right, so what we're going to do is find either the length and the width or the area of the base. So the base is a rectangle, so I need to find this distance, and I need to find this distance. So let's look at the distance down here in green first. So that would be 8.5, right? But we folded up x on each side. So that means that this leftover length is 8.5 minus the 2 x's that I folded up from both sides. We have an x here and an x here, so that's been folded up. Same thing's going to happen on the other side. We would have 11 minus the 2 x's that we fold up there. So the area of the base is going to be 11 minus 2x. That's this length, however you want to say it, times this distance here, times the height. So that would be the volume. Okay, phi of x. So there's my function. The volume is 11 minus 2x times 8.5 minus 2x times x. So what I'm going to do now is graph this. So if we look at this before we graph it, though, this is just a polynomial that we've been dealing with, right? You should look at it and say, oh, this is a third degree. 1, 2, 3 x's. So it's a third degree. So let's go into Desmos. Let's type that equation in. All right, pause this anytime you need to. I'm going to type that in. Y equals parentheses 11 minus 2x parentheses 8.5 minus 2x, 8.5 by 11 sheet of paper, times x. All right, now I need to go back. I don't know why I lost my, there it is. Okay, so here's my volume curve. All right, and here's my purple dots, which represent volumes. Now, it's interesting that some people maybe didn't quite get their volume figured out correctly. All right, we don't want to exactly point fingers, but we will say that the one person who did the 1/2, okay, which is right here, all right, they did their volume correctly. All right, so you might remember who that was, who had the 1/2 inch there. All right, and then let's see, we had a couple other ones here that are good, but I'm not too sure what's happening up here at the top. Okay, so anyway, what we want to do is look at this volume curve. Notice that it is a cubic. It has that nice N shape, right? Okay, but there's parts of this curve that aren't useful for us as far as analyzing our maximum volume. Okay, so for example, if we looked at the domain of this, okay, the domain of this curve would be what? What would be our starting value for x? We talked about that on Wednesday. What's our minimum value for x? That would be 0. All right. And what's our maximum value for x? Well, about 4 1/4. Right? Because we can't have a piece of paper. We couldn't fold it up. We could fold it up, but it's not going to have any volume. All right. So look at that. Notice that curve, okay, 0, 4 1/2. Right? There's my x-intercepts right there. So those ones are set the limit or the boundaries to our volume. Okay. This one doesn't because it's outside. We couldn't have a height of 5.5. It's not. We're not going to be able to cut that out. So our maximum is going to be up here. All right. And we would think of this as a relative maximum because it goes up all the way up to here. However, if we restricted this polynomial so that we were only looking at it between 0 and 4.25, then this would have to be the absolute maximum because we're now restricting it so that it's only between 0 and 4 1/4. So that would be my absolute maximum. So my absolute volume or my maximum volume is going to be when my height is about 1.585. Now somebody took 1.5, all right, and they got it. They got 69, so they're pretty close. All right, so the 1.5, whoever chose that, picked the right one because that one's the closest to being what the maximum is. We had a 1.75, which is, again, pretty close, right? They said it was 77. They may have embellished that a little bit, but it's pretty close. So 1.58 is our maximum volume that we would want to make our box. Okay, so I wanted to kind of wrap that up for you, and hopefully we'll see you Monday.